What would you spend $7 billion on? You could buy about 35,000 Ferraris, build 6 stadiums on the scale of the Sophie Stadium, or purchase an aircraft carrier-sized yacht, and still have plenty left for personal expenses. But Airbus spent that money differently. They practically threw it out the window, all because French and German engineers were using different versions of the same software. Once aircraft parts from different countries started coming together, it turned out that 530 kilometers of wiring didn't fit. The cables were just a bit too short. Everything had to be taken apart and rebuilt from scratch. The result was a 2-year delay and $7 billion down the drain, all before the aircraft even made its first flight. Welcome aboard the Airbus A380, the largest passenger airplane in history. Its creation story isn't just an engineering triumph, it's also one of the most expensive setbacks in aviation history. In the mid-90s, air travel was booming, and the world's biggest airports were running out of space. Heathrow Airport was operating at the edge of its capacity, and so were the airports in Frankfurt, Tokyo, and Dubai. There was no room for new runways. Land was scarce, nearby residents pushed back over noise, and authorities wouldn't issue permits. The only workable solution was having fewer planes that could carry more people. Airbus pitched an idea that sounded obvious once you heard it. Instead of 100 flights with 200 passengers each, why not run 50 flights with 500 passengers? More travelers, fewer takeoffs. At the time, Boeing controlled the long-haul market with the Boeing 747, the legendary jumbo jet introduced in 1969. But Airbus wanted that crown. They launched a new program called A3XX and put it in front of airlines, letting orders decide its fate. They also baked a bit of strategy into the name. The final designation, A380, was chosen on purpose. In China and across much of Asia, the number 8 symbolizes luck and prosperity. The idea was straightforward. Chinese carriers would spot the lucky number and line up to place orders. It didn't pan out. In the end, the entire Chinese market bought exactly 5 aircraft. Feng Shui wasn't on their side. In December 2000, Airbus officially launched the program with a budget of about $13.5 billion. The first orders were already in. Singapore Airlines signed a contract even before the formal launch, followed by Emirates and Qantas. It looked like the market had spoken loud and clear. Boeing responded with a completely different bet. Not massive aircraft, but lightweight, long-range planes built for direct routes, like the future Boeing 787 Dreamliner. 2 fundamentally different versions of what the aviation market would look like in 20 years. Both companies were convinced they were right, and only time would tell who came out on top. But for now, the priority was building the aircraft. A single factory couldn't handle a project of that scale, so production was spread across Europe. The wings were built in Broughton, UK, sections of the fuselage came from France and Germany, the tail was made in Spain, and final assembly took place in Toulouse in France. The problem was size. The A380 components were so massive they couldn't be moved using standard transport. The solution felt straight out of a movie. Parts traveled by sea on specialized ships, then transferred to river barges, and finally rolled through 21 French towns in overnight road convoys. Bridges had to be reinforced, road shoulders widened, and traffic signs temporarily removed just to clear the way. And whenever those enormous loads crawled through at 2 a.m, residents would come outside just to watch. People gathered along the streets and applauded, not because anyone asked them to, and not because it was a celebration, but because they knew that they were seeing something unprecedented. Some even brought their kids. This went on for 14 years, the entire span of the A380 serial production. Then came the software issue. More precisely, the CATIA version 5 versus the version 4. Pride outweighed file compatibility. The result was 530 kilometers of wiring that had to be ripped out and reinstalled, $6 to $7 billion effectively wasted, 2 years lost, and several senior executives fired. It became one of the most expensive IT failures in aviation history, and nearly killed the program early on. The project survived, but the damage ran deep. The first production Airbus A380 took off 2 years late and cost far more than planned. At that point, the Toulouse assembly line was running at full tilt. The A380 is 73 meters long, with a wingspan of almost 80 meters and a total height of 24 meters, about the height of an 8-story building. Its defining feature, though, is something no other civilian aircraft has: 2 full-length passenger decks running the entire fuselage. Not a small upper business section like on the Boeing 747, but 2 complete floors of seating from nose to tail. A typical A380 carries 550 to 600 passengers. The theoretical maximum is 853 seats, more than any other mass-produced commercial airliner. The wings were so wide that the A380 couldn't fit standard terminal gates, so airports had to build dedicated ones from scratch. But the most dramatic moments came during destructive wing strength certification. It failed at 5% short of the required threshold. Photos of the wing bent sharply upwards spread across aviation media and looked genuinely unsettling. Engineers rushed to reinforce the structure. Then, in 2012, a more serious issue surfaced. Thousands of small aluminium alloy components inside the wings of aircraft already in service were developing cracks. Microfractures even showed up in wings still sitting in storage that had never flown. An Airbus representative later admitted, "We didn't fully understand the material properties. Fixing each plane added 8 weeks of downtime." Here's a detail that's hard to wrap your head around at first. Inside, the A380's wings double as massive fuel tanks with a total capacity of more than 320,000 litres. That's roughly enough to fill 3,500 cars to the brim, or 7 standard Olympic swimming pools. A single flight from Dubai to Los Angeles burns so much fuel it could heat a small town for several months. The A380 flies with 4 engines, either the Rolls-Royce Trent 970 or the Engine Alliance GP7200. Each produces about 340 kilonewtons of thrust. Together, it's like 4 locomotives pulling at once. Even so, fuel efficiency per passenger is surprisingly solid at around 3 litres per 100 kilometers. That's less than a typical SUV, simply because there are so many people on board. The maximum takeoff weight reaches 575 tons, about the same as 1,500 cars lifted into the air at once. This metal and composite giant touches down at just 240 to 250 kilometers per hour, roughly the same landing speed as a Boeing 737, an aircraft about 3 times lighter. That's no accident. The enormous wings generate huge lift, even at lower speeds, so the giant practically glides onto the runway. Its aerodynamics are tuned for a smooth landing, despite the fact that we're talking about a 500-ton aircraft. If you've ever flown economy on an Airbus A380, you probably remember how quiet it feels. The 4 engines sit farther from the fuselage than on most aircraft, and their design keeps noise from reaching the cabin. Vibration is minimal, so the whole experience feels unusually calm and steady. Passenger surveys consistently rank the A380 among the most comfortable aircraft to fly, even in standard economy with regular seats and legroom. The upper deck, though, shows what's possible when space and budget aren't tight. Emirates installed real shower suites on its A380s, complete with hot water, heated floors, and a 5-minute limit so onboard supplies don't run dry. Freshen up, then head to the bar, cruising at 12,000 meters above the ground. Etihad Airways decided that still wasn't enough and introduced the Residence. It's a 3-room space in the sky. A bedroom with a bed, a living room with a sofa, and a separate bathroom with a shower, plus a personal butler. The butler is trained at the London Butler Academy and stays with you from takeoff to landing. On some routes, the price of that experience exceeded the cost of a used car. Now let's talk about the famous Emirates bar on the upper deck, which was designed from day one with a backup plan. If the concept flopped, the entire bar could be removed in 96 hours and replaced with 8 standard passenger seats. Management clearly had their doubts, but the bar became iconic, and the seats never took its place. How do you handle an aircraft with an 80-meter wingspan? The cockpit follows the standard Airbus philosophy: side-stick controllers, a fly-by-wire system, and flight computers that physically prevent pilots from exceeding structural limits, even if they pull the stick all the way back. The scale, though, changes everything. The wing control systems alone, including flaps, spoilers, and slats, rely on multiple independent hydraulic and electrical circuits operating simultaneously. If one fails, the aircraft keeps flying. There's another unusual feature on the ground. While taxiing, the rear landing gear sets steer independently. Without that feature, an aircraft this long simply wouldn't fit standard taxiways. Pilots go through specialized training to handle crosswind landings. With an 80-meter span from wingtip to wingtip, even a small roll error in the final moments before touchdown can have serious consequences. That's why in November 2010, when an engine on Qantas Flight 32 exploded and around 50 warning alerts fired at once, the 5 pilots who happened to be in the cockpit flew the aircraft manually for more than an hour. The evacuation certification test took place in Hamburg with 853 volunteers, in total darkness using inflatable slides. One participant broke a leg and 32 suffered friction burns, but regulators ruled the losses acceptable and granted certification. The aircraft was evacuated in 78 seconds instead of the required 90. The engine failure mentioned earlier came down to a manufacturing defect. An oil supply pipe was thinner than specified by fractions of a millimeter. The oil overheated, caught fire, and the engine disintegrated. Debris punched through the wing, damaged part of the hydraulic system, and triggered roughly 50 simultaneous system failures. The crew spent several hours trying to figure out what still worked and what didn't. They landed in Singapore with 0 casualties among the 469 passengers and crew. The Airbus A380 withstood something it was never meant to withstand. For context, the aircraft's first commercial flight had taken place 3 years earlier in October 2007, with Singapore Airlines on the Singapore to Sydney route. Tickets for that flight were auctioned off, and the earliest passengers paid about as much as a used car just to be the first on board. The A380 was so unconventional that the International Civil Aviation Organization had to create a new aircraft category when it entered service. Until then, the highest weight category had been heavy. Now there was a new one, super. In practice, that meant special separation rules on approach. Any aircraft flying behind an A380 had to wait longer than it would behind any other plane. Airports worldwide that handled the A380 updated their procedures immediately. The single aircraft forced changes to the global air traffic system. Airports also had to reinforce their taxiways because standard pavement wasn't built for that kind of weight, and some aprons were widened so the A380's wingtips wouldn't come too close to neighboring aircraft during ground maneuvers. The reason is wake turbulence. 2 powerful air vortices trail behind the aircraft and take a long time to dissipate. On the A380, they're strong enough to flip a lighter aircraft that wanders into their path. How strong are we talking? In 2017, a Bombardier Challenger business jet was flying over the Arabian Sea when it crossed the wake of an Emirates A380. The jet rolled 3 times and dropped 2,700 meters. The passengers and crew were injured. After landing, inspectors found the fuselage had warped. The stress loads had literally bent the structure. The aircraft was written off. By then, the A380 was long gone, and its crew had no idea anything had happened. Once an A380 touches down, the clocks start ticking. Ground crews have about 90 minutes to deplane everyone, clean the cabin, restock catering, refuel, board the next passengers, and push the aircraft back for departure. If they miss the window, airport operations start to collapse. Every A380 gate runs on a tight schedule, and one delay can trigger hours of knock-on disruptions. The workload isn't even comparable to a typical aircraft turnaround. There are between 14 and 24 flight attendants on board. Thousands of meal trays are loaded across multiple cabin classes with different menus. Hundreds of suitcases are sorted into the cargo holds. Refueling happens through hydrant systems connected directly to the wings because there's no room to position a standard fuel truck next to a fuselage this large. A single refuel involves hundreds of thousands of liters. Airports built dedicated dual-level jet bridges with separate corridors for the lower and upper decks. Without them, boarding 500 passengers would take forever. Cleaning is its own large-scale operation. 2 full decks, multiple restroom blocks, bars, and shower suites. Some airlines even maintain ground teams assigned exclusively to the Airbus A380. Airbus expected to sell around 700 A380s. The idea made sense. Major hubs were overloaded, and airlines relied heavily on the hub-and-spoke model, where smaller cities feed traffic into a central hub and most connections flow through that core. But the market, slowly at first and then all at once, shifted in a different direction. Boeing introduced the Boeing 787 Dreamliner, and Airbus answered with the Airbus A380. Both were long-range, fuel-efficient jets carrying about 250 to 300 passengers, built for non-stop service between smaller cities without routing everyone through a mega-hub. Why funnel 500 passengers through Dubai if you can fly directly to a less crowded destination? One by one, airlines revised their strategies. Some, including Air France and Singapore Airlines, started retiring their A380s earlier than planned. In the end, only 251 aircraft were built. One number explains the outcome better than anything else. 123 of them were purchased by a single airline, Emirates. The Dubai-based carrier almost single-handedly kept the program alive. More than half of the world's A380 fleet flew under one flag. That left Airbus unusually exposed, with a thin customer base and near total dependence on one buyer. In 2019, when Emirates scaled back its order, not cancelling it outright but simply reducing the quantity, Airbus announced the end of production. One customer effectively determined the fate of an entire aircraft program. The final Airbus A380 rolled off the assembly line in 2021. Before closing this chapter, there's one more detail that feels like it belongs in a mystery novel. An A380 engine operated by Air France came apart mid-flight over Greenland. Debris broke up in the air and scattered across the ice sheet. Investigators needed to recover a 150-kilogram metal fragment that could explain the failure, and they searched the projected debris field for 4 years. Eventually, they found it buried under 4 meters of ice. Studying that piece revealed a previously undocumented materials issue: cold dwell fatigue. This type of metal fatigue hadn't been observed in real-world aviation before. The incident literally expanded engineering knowledge of metal physics and made future engines a little safer. Today, the A380 still flies with Emirates, Singapore Airlines, Qantas and British Airways. These carriers aren't in a rush to retire an aircraft that remains one of the most fuel-efficient options on long-haul routes. The pandemic accelerated fleet reductions worldwide. When planes were grounded, airlines often chose not to bring back the largest and most expensive aircraft to maintain. Some retired A380s have been repurposed as airport hotels, where you can spend the night in a first-class seat without ever taking off. Others were dismantled for spare parts that will keep flying on other aircraft for years to come.